Let's talk about the vertical shift. Now, vertical shift, aka vertical translation, those are the same things. A vertical shift happens by adding and subtracting numbers on the outside of the equation. So let's do an example here. Here, once again, I have my amplitude is always multiplying in front. That is a secret 1 that is being multiplied. So in this problem, my amplitude is up 1, down 1. Then my vertical shift is adding or subtracting outside. So because I am adding 2, that means I am moving up 2. Now, when you are writing your shifts, and this counts for vertical shift and phase shift, please, please, please make sure that you state a direction. If you just say 2 or even positive 2, I will mark that wrong because that doesn't tell me that you know this is moving up. I need to know that you know the direction that plus 2 is moving. So whether you do arrows or you write up 2, you need to have a direction attached to your shifts. And same thing with phase shift when we get there. So vertical shift is up 2. The period, there's no number multiplying in front. It's a secret 1. So this is the basic period. We haven't changed anything. And phase shift is always adding or subtracting inside. We don't have any of that this time, so there is none. And last one, this is a sine wave graph. So let's remember how we graph these. Step 1 is our vertical shift. So I'm going to, instead of being on the x-axis this time, I'm going to move up 2 to be up here. There's my center line. Now my amplitude is still up 1, down 1. So I go up 1 to make my top boundary line, and down 1 to make my bottom boundary line. So this is a pretty skinny wave. It all has to fit in between those boundaries. Step 3 is my phase shift. I don't have that this time, so that stays on the y-axis. And my period is still 2 pi. So I'll do that the same as last time. Make sure that it's 2 pi long. And now I've created my boundary boxes. So I just need my sine wave to fit in that box. So I know it's a sine because of step 5, sine. So I make my little s, starts at the middle, then goes up to the top, back to the middle, down to the bottom, back to the middle. And there's our sine wave. Now remember, we do need to graph 2 full periods. So I'll go over the other direction. Do another 2 pi long boundary line and copy and paste the sine shape. And there we go. There's 2 full periods that fit in all my boundary lines of the sine wave shape. So now that you've practiced a vertical translation, I would like you to do the next one. So let's start by listing them together. Our amplitude is being multiplied in front, so our amplitude this time is a 3, up 3, down 3. Our vertical shift is adding or subtracting outside. This is a -1, so it's going to move everything down 1. My period, I don't have anything multiplying inside. It's that secret 1, so it's the basic period 2 pi. And phase shift, there's nothing adding or subtracting inside, so there's no phase shift this time. And finally, this is a cosine wave shape. It's a positive cosine this time, so it's going to look like that. So I want you to pause the video, graph our 5 steps, and come up with what the graph of this wave is going to look like. Let's see what you got. So vertical shift was first. I moved everything down 1. Amplitude is 3, so I went up 3, down 3 to make my boundary lines. Phase shift was none, so that stays on the y-axis, and my period is still 2 pi, so I go 2 pi out, and that creates the box for my first wave. It's a positive cosine, so it starts at the top, goes to the middle, down, middle, back up to the top. And I need at least 2 waves, so I came over and made another 2 pi long box. Start at the top, middle, down, middle, top, make a second cosine wave. And that is how we graph when we have amplitudes and vertical shifts. In the next video, we're going to add phase shifts into the mix. So we'll have amplitude, vertical, and phase shifts and talk about what to do with that.